12-3, trig functions and general angles. Objective, find values of trig functions for general angles. Find values of trig functions by using reference angles. Let's take a look at our angles that we've talked about, starting at the initial and going to the terminal. Every angle can be made into a right triangle with the x-axis right here. And here's our point x comma y, and x means our x direction here, and y is our y direction, or up or down. Now, this right triangle is going to help us figure out the sine of theta. Now, sine has been opposite over hypotenuse, and in this case this angle's opposite is the y, and the hypotenuse is the radius, and that radius comes from the Pythagorean theorem using x squared plus y squared. Cosine is adjacent over hypotenuse, and this angle, the adjacent, is x and the hypotenuse is r. Tangent, remember, is the opposite over the adjacent, and our opposite for our angle is y, and our adjacent is x. And all of these are the reciprocal versions here. Okay, let's practice finding the 6 trig functions for this point right here. So the first thing we want to do is figure out the radius. So r is equal to the square root. You're going to take x and square it, and then you're going to take negative 15 and square it, and you're going to get square root of 64 plus 225, and the answer is going to be 17 when you do that, because I know this because this is a triple. This is 8, 15, 17. So now I know all the players in the game. Now remember, this is our x, and our x is 8, and this is our y, which is negative 15. So if I want to find the sine of the angle, I'm going to do y, which is negative 15, over the radius, which is 17. The cosine will be the adjacent, or x, over hypotenuse, and then our y, which is, just look at this y, negative 15 over x, which is 8. Now the cosecant is a reciprocal of this, so that answer will be 17 over, or negative 17 over 15. You can put the negative wherever you want. And then the reciprocal of this is 17 over 8. And the reciprocal of this is going to be negative 8 over 15. And that's how we go about doing that. Your turn. And here's the answer. I actually drew the picture over here so I could see where I was. And I found that I found the cosine, and that wasn't the same for any of the other 3. So I said I knew I had the right answer. Okay, let's look at a quadrantal angle. And those are angles that where the terminal side is on one of the axes over here. So this is a angle of 0 degrees. This is an angle of 90 degrees, angle of 180, angle of 270 degrees, in degrees and radians, Okay, let's go ahead and find, we have this terminal side here. So we know that we have this angle here, and their terminal side is here. So I don't know whether we go positive or whether we go negative. It doesn't matter because I'm ending up in this place. So let's go ahead and figure out all our players. R is equal to the square root, and our x is 0 squared plus negative 2 squared. So the answer is just 2. So your radius is going to be 2. And remember, our x is 0, and our y is negative 2. And so now we can go ahead and find all our trig functions. So y is negative 2 all over 2, or we can say negative 1. And then this is going to be 0 over 2, and that answer is 0. And then this is going to be y, which is negative 2 over x, and this is undefined. And then this is going to be the reciprocal of this, which is negative 1. That's going to be reciprocal of this, and if I turn this around, 2 over 0, I'm going to get undefined. And over here, I'm going to turn this around, and it's going to be 0 over negative 2, which is 0. So now I have found all 6 values. Go ahead and check your progress and see if you can find which one is incorrect. And here's the answer. The incorrect one was this, sine of theta. I went ahead and graphed it, 3, 0. and my y is 0, and my radius is 3, so that should give me a 0, and over here it says 1. All right, let's talk about reference angles. When we have these big angles here, in order to figure out the trig function, it's easier to use the reference angle. And the reference angle is this angle. It's made with the x-axis and the terminal side. So x-axis and terminal side. This is already a reference angle. This will be the reference angle because it's made with the x-axis and the terminal side. This is the reference angle because it's made with the x-axis and the terminal side. And then this is the reference angle because it's made with the x-axis and terminal side. And you can find all these angles by either subtracting from 180 or subtracting from 360. Okay, let's go ahead and practice a problem. And we want to sketch 360 degrees and then find the reference angle. Okay, so this is 0 degrees. This is 90, this is 180, and then this is 270 degrees. So here is the initial, and I know I have to go all the way around and past 270, and then this angle will be 330 degrees. Okay, 330 degrees. Now, to find the reference angle, that's this angle right here. This is the reference angle made with the x-axis and the terminal side. And to figure out that angle, we'll take 360 degrees, take away 330, and that angle will be 30 degrees. So we say this reference angle is 30, and we always use a positive number. Okay, let's do it again. Now this is negative 5 pi 6, so this is 0 and radians, and then this is negative pi half radians, and then this is negative pi radians. Okay, now negative 5 pi 6, that's over halfway. Okay, so 5/6 is over halfway. So here's my initial, and my terminal will be right about here. And this is negative 5 pi 6, because it's not quite negative pi. I'm not that big there. So this is going to be negative 5 pi 6. Now my reference angle will be over here. This will be the angle I'm looking for, theta. And to get theta, I'm going to just take pi, and I'm going to subtract 5 pi 6, so I can see the leftover to get to pi. This is 6 pi 6 if I get a common denominator, and then the answer is pi 6. So this angle right here is a reference angle, and it's always in positive form, pi 6. Okay, your turn. And here's the answer. Your turn. And here's the answer, pi 4. All right, so all the trig functions, depending on where the point is, will determine whether the trig function is positive, negative, and such. So and really, we know everything is positive here because the x and the y are both positive. Over here, we know our x here is going to be a negative value, and our y is going to be a positive value. So every time we use x, we're going to have a negative value here. So all of these, I should say all of those are negative. So anytime the x is being used, which is this and this, they're going to be negative values. In this quadrant, both the x and the y are negative, and when that happens, then when x and y are both negative, then that's going to give us a positive number. Otherwise, everything is negative. Over here in this quadrant, the x is positive and the y is negative. So anytime you're using a y, you're going to have a negative value. So these use y and these use y. Okay, let's go ahead and use a reference angle to find a trig value. So this is 135 degrees. So this is 0 degrees, 90 degrees, 180 degrees. This is our initial. This is going to be our terminal, which is 135 degrees. So what we want to do is we want to find this reference angle. So I'm going to take 180 and subtract 135, and that's going to be 45 degrees. So my reference angle is 45 degrees. Now, let's go ahead and draw a 45, 90. So this is 45 degrees, and you know, in a 45 degree we have this relationship of 1, 1, root 2. Okay, so you can think about this point right here as 1, comma 1. Okay, and you know the radius right here. So the sine of 135 degrees is going to be y over r. We already know our r. R is root 2. And our y right here is positive 1. Oh, this should have been a negative right here. 1. And so our answer is 1 over root 2, which we like to write as root 2 over 2 in rationalized form. Okay, let's do another angle. This is cotangent of 7 pi thirds. 7 pi thirds. Now, 7 pi thirds is the same as 6 pi thirds plus pi thirds. Now, 6 pi thirds is another way to say 2 pi. So this is going all the way around and then over 1. So this is 0. This is pi halves, pi, and 3 pi halves. So here's our initial. We're going to go all the way around 2 pi, and then we're going to go up pi thirds. Not quite pi halves, but pi thirds. And I'm going to go ahead and draw this in another color. And so here is, this is the angle right here. And going all the way around is 7 pi thirds. But I know my reference angle is pi thirds. So this is pi thirds. Now, remember what pi thirds is. Pi thirds is, pi is the same thing as 180 over 3. So this is like using a 30, 60, 90 triangle. So I'm going to draw a 30, 60, 90 triangle for you. And we know in a 30, 60, 90, this is 1, this is root 3, and this is 2. That is the ratio in a 30, 60, 90 triangle. I'm trying to find the cotangent of 7 pi thirds, which means I want to use x over y. So this point, if I go over 1, and then I go up root 3, so this is going to be x, which is 1, divided by y, which is root 3, and we rationalize root 3 over 3. And so that's the exact value. Okay, let's pause, have you draw that, and try to find the sign. And here's the answer. And I'm going to do this for you. Find the exact value of cotangent 11 pi over 2. 11 pi over 2 is 8 pi over 2 plus 3 pi over 2. And this is 4 pi plus 2 pi over 2. So this is 2 revolutions going all the way around twice, and then going 3 pi halves. Remember, this is 0, this is pi halves, this is pi, and this is 3 pi halves. So the terminal side will be right here, and this is going to be our point, 0r. I don't know what the radius is. We'll just call it r, and you're going to find it really doesn't matter. So the cotangent of 11 pi halves is x over y, and our x is 0, and it doesn't really matter what r is because our answer will be 0.